Hi, and welcome to Math for All, where everyone can learn more about math. Today, we are embarking on the language and symbols of square roots. We'll be learning about taking square roots, perfect and non-perfect squares, the radical symbol, using a calculator to estimate them, and what is so special about them. So let's get started. First, a super quick review. 3 squared equals 3 times 3, which equals 9. We're going to do the opposite of squaring 3 by taking the square root of 9. Notice the slight difference in wording in that. We indicate taking the square root by a symbol that looks like a division symbol, but it's pointy like this and is called the radical. It means what number times itself equals what's under the radical. Examples, the square root of 25, or what number times itself equals 25. The answer is 5, because 5 times 5 equals 25. The square root of 49 means what number times itself equals 49. It's 7, because 7 times 7 equals 49. Notice that you do not divide the number under the radical by 2. That's a no-no. To help in answering these types of problems, let's quickly go through the perfect squares that we should remember. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. So, the square root of 81 equals 9, and the square root of 16 is 4. See how it works? Cool beans. Now let's transition to where we have to find a square root of a number that is not a perfect square. For that, we will have to use a calculator, which can be kind of fun. An important bit is that when we take it out of the radical, it is only an estimate, not the exact answer. Because the square roots of non-perfect squares are decimals that never end or repeat. Math people call these kinds of numbers irrational because they don't behave. So for kicks, let's use a calculator to find the square root of 2. You should find the radical button on your calculator. Put in 2 and then equals. You will see a number such as 1.41421135562. This irrational, misbehaving number keeps going on forever. Now we can check and see if indeed I multiply it by itself, it will equal 2. I don't like inputting all of those decimals in, so I'll just do 1.4 times 1.4, which equals 1.96. That's pretty close to 2, but not quite. We'll give it the next decimal place for 1.41 times 1.41. That equals 1.9881. Now we're talking. Each decimal place will get me closer and closer to 2. This shows you that when you take away some decimals, it is not exact anymore. We will now practice finding the square root of 54, rounded to the nearest hundredth. Using a calculator, push the radical button, then 54, and then equals. You will see the number 7.3484692. Here's a refresher on rounding it to the nearest hundredth. The hundredths place is 2 after the decimal point because 100 has 2 zeros. So this 4. Then we look at the very next number, the 8. If that number is 0 through 4, keep the 4 the same. If it's 5 through 9, bump the 4 up 1 to 5. That 8 is obviously between 5 and 9, so the 4 rounds up to a 5 and the rest of the numbers go away, for an answer of 7.35. The square root of 54 is approximately, shown by that squiggled equal sign, 7.35. Finally, one very special property of square roots is that we cannot take the square root of a negative number. So, if you see the square root of -9, it does not equal -3. Because -3 times -3 doesn't equal -9. It would equal +9. So you would write no real solutions, implying that there are imaginary solutions, which you're going to learn about in Algebra 2. Now, the negative sign can be on the outside of the radical, such as negative square root of 25 does equal negative 5. Awesome. This was a lot of information on the language of square roots, which are so powerful. There is so much more to learn about actually using them, so please come back soon to keep learning more about math.